To understand the value of pooled data analysis, we want to give you examples from biology, chemistry, physics, geoscience. Right now we're going to take a little example from physics, the concept of buoyancy and density. And from anywhere on the HP Catalyst website for CSCS, you can go to the CSCS investigations over here. And we're going to look at one that is actually in California is considered a middle school standard, and that's on the concept of density and buoyancy. And we're going to look just at density here. But the big question is really what causes something to sink or float. So in a traditional activity, we define the concept of density, at least at the middle school level, as mass divided by volume. And then we can start doing some predictions. Of course, it gets very complex when you're dealing with complex shapes and so forth, like a boat, and you really need to understand the concept of buoyancy, which is really introduced more in a physics concept. But nonetheless, students are interested in this concept of what causes something to sink or to float. And what we're going to do is we're going to look at a couple examples here of things that are sinking and floating. So you're probably familiar with the density column. Here's one where we have honey on the bottom, and then followed by Caro syrup and water, and then actually dish soap and water and oil. And these have different densities, and so they're going to layer out appropriately based upon their densities, because these are fluids and can flow. They're going to layer out in that way. Well, in this activity, we're going to try to answer the question as to why does oil float on top of water, or why does honey sink beneath Caro syrup. But we're going to do it inductively, where the students are going to come up with their own explanations rather than being told that it's simply a ratio of mass to volume, and if the mass to volume ratio is greater than that of water, it sinks, and if it's less than that, then it floats. But so for right now, we're going to be using a common material known as density blocks or buoyancy blocks. We won't call them such. They're just blocks of various different materials. You can see there's aluminum and iron and nylon and copper and acrylic and so forth in here, in various different types of woods. And the first thing we would have them doing is predicting what they think is going to sink or float if we just put a single cube into the situation. So here's into the tub of water. So here's a number of different cubes, and they're going to record their predictions in a simple table. So if they think that acrylic will float, they would do that. If they think that brass would sink, they would do that. At the end of it, they would submit their results. So when you submit the results in this, it's going to go into a data table. Again, the form goes directly into a spreadsheet which is linked to it. And then the predictions will come out, and we can start to see that here we have a total of 76 respondents in this. And we can see that not everybody thought that acrylic would float. The majority of people did, but some people thought it would sink, and some people thought it was neutrally buoyant. When it came to brass, pretty much 100% of the people thought that it would sink, and so forth. And you can see the predictions. And the interesting thing is that for students to see right up front that even though we haven't tested anything, that we want to be predicting. We're doing hypothesizing and so forth. We're testing a hypothesis. For example, the hypothesis, will ironwood sink or float or be neutrally buoyant? And as you look at this data, you can see obvious trends and patterns. And one of the big things about pooling data is to be able to see trends and patterns that would otherwise be invisible. So normally, in a traditional setup, that the students would just do their own predictions and wouldn't see the predictions of others. But not in a CSCS lesson. In a CSCS lesson, that they are going to be investigating things in the context of what their peers are doing. So in this case right here, we'll first ask them, will these blocks sink or float when placed in water? They do some predictions, and then they can test those. The next thing we're going to ask them to do is that to make combinations of these blocks and see if they will sink or float but at the same time we're going to have them measure their mass and their volume. Now, since these all happen to be the same volume, that makes it a pretty easy calculation. But you could use different materials where they might actually have to go calculate the volume individually. But these are common blocks used in middle and high school experiments and activities. So you can have them mass a single block and then mass 2 blocks just by simply tying them together on with a rubber band, and subsequently try 3 blocks and 4 blocks and 5 blocks. And so in each of these cases, they're going to try to find one combination that just floats and one combination that just sinks. In other words, they're kind of aiming for neutral buoyancy. So there's some kind of a challenge here as well. Can they actually make a neutrally buoyant column by rearranging these blocks? And if you have number sets of them, then of course they can have multiple types of the same type of a cube. So once that they've measured the mass and the volume, in this case just would be 5 times the volume of one block, they are going to place them in a container. And here you can see that this 5 block combination with brass in the bottom and nylon and then 3 woods is definitely a sinker. And so they would classify that as a sinker. They would then try another 5 block combination and get it as a floater. And they're going to record whether they're sinking or they're floating. So they'll do it for all different block combinations, for 1, 2, 3, 4, and 5 block combinations, and then recording again if they're going to be sinking or floating. Now, what they're doing is they're going to be putting them into a form. So in here it's going to be a data table, and you can see that this is actual data from teachers that are preparing to teach students. But this is a spreadsheet. It happens to be a Google spreadsheet, online spreadsheet, and they can see for one block here for Sylvia, Dan, and David, they had for one block would be a volume of 16.4 milliliters or 16.4 cubic centimeters. And they had one that floated at 6.6 grams, and they had one that sank at 21.9. Then as they went through here, they tried a 2 block combination, and they found one that floated. It happened to have a mass of 18.1 grams, and one that sank that happened to have a mass of 40.4 grams. And so they would continue trying to find a sinker and a floater all the way down to 5 blocks. But they're not alone. Meanwhile, Giovanni and Karen, or Susan and Ryan, or Sam and John, these other groups are collecting their data, and all of this data is going to be pooled. Because it's in a spreadsheet, we can aggregate that information and be able to examine it together. So you'll notice one of the advantages of this is that sometimes groups don't get complete data. So for example, Joseph, Daniels, and Henry, they just started by the time the bell rang. These other groups and so forth were a little bit faster, but you can see that there's incomplete data. Well, in a normal laboratory, that'd be kind of a problem, but not in a CSCS laboratory because you're pooling the data. Now, they do look at their own data, but they look at it in the context of whole class data. So if we look over here at the plot of student data, which is just taking that data and putting it on an XY graph here of mass on the y-axis versus volume on the x-axis, or I should say, a plot of mass versus volume here, we can see that the red dots here represent those combinations of blocks that sank, and the blue ones indicate those combinations of blocks that floated. Now at this point, you ask the students, to look at this data and see what they can hypothesize or predict or maybe explain even from this data. And of course they're going to look at the data and they're going to start to see a definite pattern. They're going to see a definite pattern between the floaters and the sinkers, and almost invariably one student in each group is going to say, hey, wait a minute, it looks like there's kind of an invisible line that separates the blue from the red. The more astute students are going to start to look at that and actually calculate the slope and realize, okay, that has a slope of 1 gram per milliliter. Now again, you haven't introduced the concept of density, so they wouldn't necessarily know that water has a density of 1 gram per milliliter or 1 gram per cubic centimeter. But by looking at this data, that trend is so apparent that most students are going to say, I think it has to do something with the mass to volume ratio. And anything which has a mass to volume ratio greater than 1 is going to be a sinker. And anything which has a mass to volume ratio less than 1 looks like it's going to be a floater. Now, at that point, you can then introduce the concept of density because they've, in a sense, discovered it on their own. They wouldn't have been able to discover it had they just had their few data points, particularly those lab groups that were not able to finish by the time the bell rang. So again, this gives you kind of an idea for the value of pooling the data and being able to analyze large sets where trends and patterns are visible that otherwise would not be visible with just a single set of data.